Okay, now that you have some ETH in one of the test networks, and I'm just using Coven over here, then we can go on and deploy a smart contract on a real blockchain. And we're going to do this with Remix and with the Injected Web3 provider. Now let me show you how this works. Let's start with a sample smart contract. I have a new Remix over here. So if you have something in there, fine. If you have nothing in there, also fine. I'm just going to write a sample contract. And it doesn't really matter how this contract looks like. I'm just going to use the same messenger that we did before. And then we are getting one string, public, my string, hello world, and we are going to add a function, update string, new string, public, my string is new string. Okay, let's use this smart contract over here, and we are going to deploy it to Coven or to one of the test networks and see how this works from Remix. Autocompile. I have a new browser over here. This is why I have to reset the settings. Go to the Deploy and Run Transactions tab, and now we are choosing the Injected Web3 provider. What will happen, or what should happen, is that MetaMask pops up and asks us which of the accounts do we want to connect with this website. And if we hit, like if you say the first account and hit next and connect, then the account will pop up over here. The way this works is that MetaMask will inject itself as a Web3 provider into the website, and the website can then, from the window object, can attach itself to the Web3 provider and then get some information from MetaMask with the classical Web3 Web3.js, Web3 JavaScript library functions like web3.eth.getAccounts, which we're going to talk about later. So don't worry about it. What you need to understand is now with Injected Web3, we are going through MetaMask to the blockchain. So Remix, MetaMask, Infura blockchain. And we see this over here. We are connected to the Coven network, has a network ID of 42. Mainnet has a network ID of 1. Accounts, we only see one suddenly because that's the account that we have connected with Remix. And if we hit deploy, then instead of having a check mark over here directly, we actually need to deploy the smart contracts by confirming a transaction with MetaMask. And if we hit here confirm, then it takes a little bit. It's not instantaneous. We can also view it on Etherscan. It will open up a new window with the Etherscan Coven Block Explorer. So that one might take a while, maybe a few seconds, maybe a minute. And then we have our transaction over here. And if we open it up, we can see all the transaction details that we already saw before. We can also interact with our smart contract here on the left side as usual. So if I hit my string, interestingly, this one is more or less instantaneous. Why is that? Because a call doesn't need to be mined. A call is just a reading operation. It doesn't need mining. It doesn't need to be baked in a block. The information is already there. It's also virtually free, and I don't have to click anything in MetaMask. But if I want to update the string to hello girly maybe, then again I need to send the transaction. That transaction has data. The data looks like this. If it shows us the data, maybe just the hex data. So the data is encoded. It is encoded in a special way. And if we confirm this, then a new transaction is sent on the blockchain. So it's a different transaction, but from the same account. This one is a contract creation. If I hit refresh, then we were sending a new transaction hash to this contract over here, and with this data field, special encoded data field. You see the exact same nonce and everything else. We didn't send any value. Now, while we are talking about the data field later and how the contract addresses are generated later, what I want to talk about in this particular section is how to send Ether from and to a smart contract, because that's one of the backbones of how DeFi and so on works. So in the next lecture, I want to see if we can send transactions with Ether to the smart contract and send it back again.